Hello, my name is Mary Harrison, and for my presentation, I decided to talk about radiometric dating. So what is radiometric dating? It includes all forms of age determination based on the nuclear substance of naturally occurring isotopes. This form of dating works by calculating an age in years by measuring the presence of a short-life radioactive element or a long-life radioactive element plus its decay product. So this is typically used when geologists are trying to determine the age of fossils or rocks. So the uses for radiometric dating: geologists use radiometric dating to determine the age of a certain rock or fossil they are interested in. It is used alongside relative dating to define the boundaries on the geologic timescale. So they use it along with the rules of principal horizontality and things like that. And it's used to determine the ages of the geologic timescale, so break things up into periods and epochs and eras. How it works. So as a rock ages, it begins to gain or transfer electrons in order to form a more stable isotope. Next, scientists utilize half-life to determine how old a rock or fossil is. Half-life is defined as the length of time it takes for 1/2 of the original atom to decay into an atom of the new isotope. Various methods are used for various materials and ages. So in this graph, as you can see, when the rock is formed, a newly formed mineral has a 100% of the parent rock and none of the daughter mineral. And after one half-life, it's 50% parent and 50% daughter. And then by the time 4 half-lives have come about, there's about 6% of the parent and then the rest is the daughter. So it just constantly decreases until it becomes fully a daughter material. So here's one example of scientists using half-life to determine the age of material, specifically carbon-14 dating. So carbon-14 dating can only be used on organic organisms after they die. It is used on relatively new organisms. It cannot be used on organisms over 60,000 years old. As organic matter decays, the carbon-14 within the organism decays into nitrogen-14. So to estimate the age, scientists can compare the ratio of carbon-12 that is still in the organism to the carbon-14 that is left that hasn't decayed into the nitrogen-14. So here's a good graph of it. So while the organisms are still alive, they gain C14 from the atmosphere and they intake it, and then they also lose it through decay and through excretion and things like that. But after they die, they aren't gaining any of the C14, but they're still losing it due to the decay. So you can estimate the age by comparing the ratio of carbon-12, which stays within the organism, to the carbon-14, because during life they are relatively equal. And here is my works cited. Thank you.